Lesson 5-1, Graphing Quadratic Functions. Here's standard form for a quadratic function. F of x equals ax squared plus bx plus c. A, b, and c here really could be any numbers. Ax squared is called the quadratic term, bx is a linear term, and c is the constant term. The graphs of these functions are called parabolas. So this is a graph of a quadratic function. A parabola is a U-shaped graph. Kind of three key things to the graphs here are the y-intercept, the axis of symmetry, and the vertex point. So the y-intercept is where the graph crosses the y-axis, and on this graph the y-intercept is right here at 0, -2. The axis of symmetry, every parabola is symmetrical, and the axis of symmetry is the vertical line of symmetry. And in this case, it kind of looks like the axis of symmetry is close to an x value of -1. So points on either side of this line should be mirror images of each other. That's the axis of symmetry. And the vertex is on the axis of symmetry. The vertex is either the bottom of the graph, the bottom of the U, or the top of the U if it happens to be upside down. So the vertex is kind of the center of the parabola. Given any function here, you can figure out these three parts of the graph. The y-intercept is always the constant c. And that makes sense because the y-intercept has an x value of 0. And if you plug in zeros into this function, this term will wipe out, the middle term will wipe out, and you'll be left with the constant. So that's easy to find. The axis of symmetry you can find by using this formula. The x value for the axis of symmetry equals -b over 2 times a. And b and a come from the equation, from the linear term and the quadratic term. And the vertex, because it's on the axis of symmetry, has an x value of -b over 2a. And if you wanted to find the y value, that ordered pair, you simply would plug in the x value and figure out what the ordered pair is. So using these ideas, we're going to graph the function 2x squared minus 8x plus 9. Today I'm going to show you how to do it by hand, and then we'll talk more about doing it with our graphing calculators tomorrow in class. So the first point that I want to plot is the y-intercept. That's an easy one. The y-intercept has to be 9 because that's what the c value is here, the constant. The next thing I'm going to do is find the axis of symmetry. So that formula is x equals -b over 2 times a. And in this case, b is -8 and a is 2. So I'm going to plug in those values into the formula, and I'll get a +8 over 4 or +2 for my axis of symmetry. If you want to, you can draw that in on your graph. You certainly don't need to, but x equals 2 is this vertical line right here. And I know that this happens to be the center of my parabola, the line of symmetry. Okay, now that I know that the vertex is on 2, somewhere on that axis of symmetry, I'm going to create a table, and I'm going to center my values around the middle, which would be 2. So the values that I would choose to plug in would maybe be 0 and 1 and 3 and 4, along with that 2, and I'm expecting that this is my vertex point. That's the center of the graph because it's on the axis of symmetry. Okay, so starting with 0, if I plug in 0, I get 9, that's my y-intercept. Now I'm going to plug in 1 into the equation. 2 times 1 minus 8 times 1 plus 9. Let's see, that gives me 2 minus 8, -6 plus 9 is 3. Now I'm going to plug in 2. 2 times 2 squared, well that'd be 2 times 4, 8. I'll just kind of write it in here. Minus 8 times 2, that's 16, plus 9, I got -8 plus 9, I get 1. That's my vertex point. Now I'm going to plug in 3. 2 times 3 squared, well that's 2 times 9 or 18, minus 8 times 3, that's 24. And then if I add 9, looks like I'm going to be at 3. And then finally, if I plug in 4, 2 times 4 squared, that's 2 times 16 or 32, minus 8 times 4, which is also 32, that gives me 0, plus 9 gives me 9. Now, I should expect to see this in my table. If I know that 2, 1 is the vertex, and x equals 2 is my axis of symmetry, then I should see points that are symmetrical on either side of that center point, that vertex. So real quickly here, here's what the graph looks like. I've got 0, 9 already. There's 1, 3, 2, 1, 3, 3, and 4, 9. And you can see that it's forming my U-shaped graph or parabola. And it's perfectly symmetrical, if I can draw it neatly. Well, that's pretty bad, but you can make yours neater than mine. It's perfectly symmetrical around this center line. And yes, it's not very neat, but make sure that you're drawing it as a curve. It's really not sharp lines here. And it continues on forever in this positive direction. Okay, let's try another one. Now you have to be careful with the way the equation is set up, because this one says 3 minus 6x minus x squared. It's kind of backwards here. It's not written in standard form. So I'm just going to rewrite it. I've got a negative x squared. That means a is negative 1. Minus 6x. That means b is negative 6. Plus 3. That means c is 3. My constant is 3. That's my y-intercept. Okay, now let's find the axis of symmetry so I know where the center of the graph is. Again, the formula is negative b over 2 times a. So if I plug those in, I'm going to have a double negative again. Negative 6 over 2 times a in this case is negative 1. So I'm going to get positive 6 over negative 2, and I get negative 3 for my axis of symmetry. You don't need to draw it in, but if you want to, tells us that this line, this vertical line going through negative 3 is going to be the line of symmetry for our graph. So it might be helpful. It also helps me choose what values I want to plug into my table. I probably want to pick negative 5, negative 4, negative 3, negative 2, negative 1, and that'll give me a nice U-shaped graph. Okay, or possibly upside down U. We'll see what happens here. So, making my table. The values I want to pick here are negative 5, negative 4, negative 3, negative 2, and negative 1. Now let me plug them in. And I'm going to just plug them into this original equation. It really doesn't matter. So I've got 3 minus 6 times 5. That's going to give me negative 5. I'm sorry, I'm plugging in negative 5. That's going to give me 3 plus 30. And then I'm going to subtract 25, and I get 8. If I plug in negative 4, I'm going to have 3 plus 24. I'm just going to do the multiplying already. Negative 6 times negative 4 will be positive 24. And then I'm going to subtract negative 4 squared, which is 16. So I've got 27 minus 16, and that gives me 11. Now I'm going to plug in negative 3. Let me just erase this. So I get 3 plus 18 minus 9. Well, that's going to give me 12. And if I'm right here, if this is the vertex, then I should see exactly the same values, 11 and 8 on the other side here. Let's just check it real quick. So I'm going to plug in negative 2. That gives me 3 plus 12 minus 4. That's 15 minus 4, or 11. And I'm guessing that this last value will be 8. Because I should see some symmetry in my table. Okay, so let me graph what I can here. Unfortunately, I didn't make my graph very good. But I'll plot some points up here. Just let me erase this. Okay, so I've got negative 5, 8. Then I've got negative 4, 11. Let's just say it's right here. Then I've got negative 3, 12, up a little higher. Negative 2, 11. And then I've got negative 1, 8. Now my next point is at 0, 3, and so if I wanted to just kind of draw the mirror image over here, I know I'm going to have a point at negative 6, 0. And here's my graph. Now, this one happens to be upside down, and that's okay. We're going to talk in a minute about, what makes your graph turn upside down. And I'm taking my time here and drawing this one a little neater. Now in this case, I have a maximum point. There's a top to this graph, top of the mountain, and it's going to go forever in the negative infinity direction. And you can see again that it's very symmetrical, and I've been a little neater this time. Okay, so how do you know if the graph is going to be U-shaped or maybe a mountain shape or upside down? Sometimes students will say there's a frown right here, frowny face, and a smile. And that might help you remember which is which. So sometimes we have a maximum value. Right here, you can see that the vertex is going to be a max because it's at the very top of the graph. And sometimes the parabola has a minimum value. And like in this case, when it's U-shaped, we've got the very, very bottom point of the graph as their minimum. This happens when that a value, the number in front of x squared, is either positive or negative. So if a is negative, you're going to see the upside down U, or sometimes students remember it because it's a frown. And if a is positive, you're going to see the regular U-shaped parabola. And students remember that because when a is positive, we've got a smile. So that's one way to remember it. Just got to remember, though, that anytime you have a negative x squared value or negative quadratic value, then your graph is going to be upside down. In other words, we're going to have a maximum. And if a is positive, you're going to see a U-shaped graph, and we're going to have a minimum point. So here's the last example. We want to state the max or min value of the function, and then state the domain and range of the function. Okay, so first of all, I'm going to study my equation here. Looks like I've got positive 1 as my a term. A is positive 1. So I know that the graph is going to be U-shaped, and that kind of helps me figure out that I've got a minimum. Okay, so the vertex point is our minimum, and we know how to find the vertex. I know that the x value for the vertex is on the axis of symmetry, so it's got to be negative b over 2a. That's what my x value is. So let's just figure that out here. I've got a b value of negative 4, and a is 1, so we're going to get positive 4 over positive 2, x equals 2. Well, that's helpful because I know that at the vertex, my x value is 2. Now, how can I figure out the y value? Well, I just need to plug 2 into the function. So f of 2 is 2 squared, that's 4, minus 4 times 2, that's 8, plus 9. Let's see what we've got here. We've got 4 minus 8, that's negative 4, plus 9 gives me positive 5. Okay, so I know that the vertex is at 2, 5. That means that my minimum value is 5. The minimum or maximum is always your y value. Okay, so if this point's at 2, 5, the bottom point of the graph is at 5. Every y value above it is higher than that. So I've got a minimum at 5. I want to state the domain and range. Now, keep the minimum value in mind here. The domain for any parabola is always going to be all reals because it's going to continue to stretch left and it's going to continue to stretch right. So my domain is negative infinity to positive infinity, no matter if the graph is U-shaped or if it's upside down. The range, however, is what changes depending on if you have a max or a min. Now, if I study my y values, remember that the minimum y value here is 5, and everything else is going to go to positive infinity. Let me draw arrows here. This graph will continue forever. So my range, I can use a bracket here because 5 is included on the graph, but 5 is the minimum value, and then it's going to reach positive infinity. So there's my domain and range. Now, if your graph were upside down, you would have a maximum point, and you would start your range at negative infinity and end it at the maximum value. Okay, try this one on your own. Same direction, state the max or min value of the function. You want to find the vertex here, and remember that the max or the min value is the y value of the vertex. And then state the domain and range, keeping in mind your max or your min.